To begin the process of removing impurities from a typical organic compound, first we will dissolve the mixed compound in a solvent, in this case, water. The solution is placed on a hot plate set between 130 and 170 degrees Celsius with a magnetic stir rod placed in the solution. More heated solvent is added until the colored impurities are fully dissolved in the water and only colorless impurities remain. After all the colored impurities have dissolved, add 25% of the total volume of the solvent in solution. Next, add approximately a gram of charcoal powder to the solution and allow it to mix on the hot plate. Once thoroughly mixed, pour the solution through a powder funnel with a fluted filter paper onto a 250 milliliter Erlenmeyer flask. This process is called gravity filtration. The reason we use a powder funnel over a liquid funnel is because the powder funnel has a wider and shorter spout that will allow for the solution to flow quicker and not allow it to cool down while in the spout, hindering premature crystal formation. Fluted filter paper is used because it allows for the filtration to occur more efficiently because it has a larger surface area and a quicker flow rate, also hindering the premature crystal formation. After the solution is cooled and crystals have formed, next you will take it through vacuum filtration. To do this, you will place a suction on a vacuum flask with a Buchner filter and a filter paper on top. After you wet the filter paper, you'll pour the crystallized solution into the Buchner filter funnel, and the vacuum will pull it through, leaving the crystals on top of the filter paper while the rest of the liquid solution flows through.
Gravity filtration is used during the previous step because A, suction filtration does not work with fluted filter paper and the powder funnel, and B, because the suction filtration can pull undesired impurities through the filter paper pores, which contaminates the filtrate. So basically, it is undesirable to use suction filtration when the filtrate is still going to be subject to analysis. Suction filtration is used as the final step because the filtrate from the last filtrate is going to be discarded and the solids in the filter paper is what is going to be quantitatively analyzed. Charcoal is used to adsorb color, colloidal compounds, and insoluble impurities from the solution. It attracts these molecules to the surface and crevices of the charcoal. Charcoal does not adsorb the dissolved compounds because it is best at absorbing nonpolar and hydrophobic compounds. Water can also compete with charcoal for adsorbing sites, which reduces its effectiveness in adsorbing dissolved compounds.
Here's a brief overview of the entire process without getting into specifics. The complete process is to dissolve the mixed compound in heated solvent until only colorless impurities are undissolved and the colored purities are all dissolved. Next, add 25% of total volume of solvent in excess to solution to avoid issues with recrystallization due to possible undissolved solute. Next, add the gram of charcoal to the solution to adsorb the color, colloidal, and colorless impurities. Once the charcoal is mixed in fully, perform gravity filtration into a 250 milliliter Erlenmeyer flask using a powder funnel and fluted filter paper, which must be wet with solvent. The filtered solution is then let cool, either at room temperature or via ice bath, depending on whether the crystals are forming properly. Lastly, the filtrate is put through vacuum filtration with a large Buchner funnel and is rinsed lightly with the solvent. The second filtrate is then discarded and the recrystallized solid is left to dry for 2 days.